My name is Chris Dickens. I'm here to talk to you today about Data Box Edge, which is one of Microsoft's portfolio of edge devices that allows for running hybrid apps at the edge. And specifically, we're going to talk a lot today about bringing sort of AI and machine learning to the edge and sort of ways to do that and what kind of things you can accomplish with it. I know you've seen this slide before, right? Like, we like to use this a lot. And it really just is about this idea that as a company, we talk about the power of the intelligent cloud and the intelligent edge. And it's more than just running things at the edge. It's the idea that you can take this amazing sort of thing that's happened with cloud computing where you can scale the cloud and use all these machines and have a centralized source of all your compute that runs across everything. But then also there's a lot of times when you need to have something running out on the edge because that's kind of where the real world is. And bandwidth can't solve all your problems between the edge and the cloud, so you have to move some things close to the edge. Satya likes to say that data has gravity, and I really believe in that as well, right? That this stuff that's getting generated out on the edge has gravity, and you have to move the compute and the processing of that thing out to the edge where it is, as opposed to trying to move all that data up to the cloud. There's just times when you can't do it that way. And so at Microsoft, we really believe in this, and we have a whole entire spectrum of kind of intelligent edge products, right? So obviously, kind of on one side of this, we have the hyperscale cloud, right, which is Azure that you know and love at Microsoft Conference. And on the other side, way down at the bottom, there's these Azure Sphere devices and microcontrollers that you see, these little tiny things. And there's really a whole spectrum in the middle, right? We have sort of normal IoT devices, and those are sort of in this kind of sensor area. But then you get into this idea of like things that run out at the edge to process those sensor data and those readings, and like be able to do things with that data out where they're getting read. So IoT Edge allows you to deploy containers out to the edge to process sensor reading, to kind of control those devices out from the edge instead of from the cloud. Azure Stack lets you run a full kind of version of Azure at your location in a fully disconnected environment. And Data Box Edge, we get kind of now to the middle, where Data Box Edge is like IoT Edge in that you can run those containers and do that compute out on the edge. But it's a much larger machine than you often think of with IoT Edge. It's a server class machine. It's a first-party device from Microsoft. And it's something that allows for sort of sophisticated edge computing out on the edge. So this is Data Box Edge. It's a one-use server device. It comes from Microsoft, right? So you don't go and buy this piece of hardware and then install some software on it and figure it out. It's actually an appliance, so you order it from the Azure portal, like you'd order anything else from the Azure portal. And then you pay as you go. So you order it from the Azure portal, you pay a normal Azure meter, and we ship you a server. And you install it in your location, and you use it for however long you want to use it for. And then when you're done, you send it back to us and you stop paying for it. It's great. So you just pay like a normal Azure meter. So you don't have to have any capital expenditure costs. It's all operational expense, all that stuff. And Data Box Edge includes a variety of capabilities. So it has in it a network storage gateway. So if you're wanting to move your data from the edge to the cloud and you don't kind of want to figure out how to sort of use the blob APIs, or you don't want to kind of teach your systems how to teach blob or how to talk blobs, or kind of use command line tools or things like that, it can sort of serve as a great pipeline for moving data to the cloud. It has edge computing, so it does full IoT Edge, runs a full IoT Edge instance. And we'll talk a lot about IoT Edge in a little bit. Sometimes people get a little confused by the naming there because they think, I'm not doing IoT stuff. But the right way to think about IoT Edge in this context is that it's a way to deploy and manage containers at the edge on your device. And so you can run these compute containers out at the edge, and that works really great for being able to sort of do whatever edge computing you want and have it all managed from the cloud. Every Data Box Edge has an FPGA in it that's powered by Azure Machine Learning. So you can do accelerated Azure Machine Learning inferences out at the edge on the FPGA. And the whole thing is cloud managed. So you can put it somewhere where you don't have IT staff because everything you do with it is done from the cloud through the Azure portal and not at the edge with the device. So we talked some about the use cases for Data Box Edge. I talked a little bit about data transfer, right? So if you have a lot of data you want to move to the cloud, either with like an existing like kind of lift and shift move where you just need to migrate a bunch of data once, Data Box Edge can help you there. Or what we see often is if people have sort of data that's kind of ongoing and getting generated all the time, and they just want to build a nice pipeline to move that data to the cloud. Data Box Edge can be great for that. You can do pre-processing of your data at the edge. So imagine all that data that's being generated and you want to move it to the cloud. But you don't actually want to move all of it to the cloud because a lot of it you don't care about that much. And so you can do things like run a compute module down at the edge that looks at all that data as it comes through and only transfers to stuff to the cloud you care about. So it saves your bandwidth. It makes it just much more kind of approachable to be moving your data to the cloud. And then, like I said, the focus today is we're going to talk about machine learning inferencing at the edge. So you can make a lot of decisions out at the edge on data, and machine learning is so optimum for this because, as we kind of all know, it's really the best at figuring out large piles of data and getting sort of knowledge about what's going on with that. Because you can kind of train the algorithm to spot sort of patterns in your data and to make decisions about it. So we'll go through briefly each of the things that I mentioned around how, what Data Box Edge is kind of built out of. And we'll start with the storage gateway. So Data Box Edge has a storage gateway, and what that looks like is at your local site, Data Box Edge will expose network shares, so either SMB or NFS shares. And this is great because almost anything can talk to an SMB or an NFS share, right? And you just have to copy files onto the SMB or NFS share, and we take care of the rest, right? So we then move any file you copy there up to Azure Cloud automatically. There's all kinds of neat stuff we can do, right? Like if your connection goes out, like we're happy to keep stuff in our cache and wait till the connection comes back. You can do kind of what I like to call like a burst copy. So like if you have like a big pile, like a terabyte of data or something that you want to move to the cloud, you're like, oh, this is going to take like 4 days to upload, and I don't want to babysit an upload for 4 days. So you can copy it at local speed to Data Box Edge, which is very fast, right? Because you can copy a terabyte over your local network pretty quick. And then you're done, right? It's on Data Box Edge. Data Box Edge takes care of the rest. It'll upload it for you. And it'll kind of make it to the cloud as it can. And if you don't want it to use that much bandwidth during your workday, that's fine. You have a bandwidth meter, right? So you can set a schedule to only use a certain amount of bandwidth during certain hours and use more overnight, that kind of thing. And I'll do one last note, which is that when you're offline, Data Box Edge has that local cache. And so you can continue to copy data to it when you're offline, and it will sort of happily take that data into its cache. And then when you come back online, it will upload it all. And on this point as well, when we get to compute, the compute continues to function offline as well. So you set your configuration when you're online. You set up all your containers and get them all running in the right way. And then the device goes offline, and those containers will keep running. And even if one fails, it'll restart and those sorts of things in order to kind of like make sure that you can continue to do your job while you're offline. And then when you come back online, everything will work again. I do want to take a moment to mention another product in the DataBox family called DataBox Gateway. So DataBox Gateway is a virtual machine version of the storage gateway functionality I just talked about. So if you're really interested in that data transfer functionality and you don't want to like get our 1U server, you can run DataBox Gateway on your own hardware, right, in your own hypervisor. And it can do all that same storage gateway functionality. So all the same, like copy into the cache, it can be offline, it's all cloud managed, all that stuff, all works with DataBox Gateway. So we talked a little bit about these sort of network data data scenarios or data use cases. And I talked some about like ongoing data pipelines. I talked some about big data migrations. I talked some about bursts of data. And I just want to kind of reiterate that those are kind of the three places we see that a lot, right? So migrating a ton of data, you just have data kind of coming through all the time. And then like when you have bursty situations and you want to do like a local copy that's fast and then let the cloud copy go as it can. And so you don't have to teach your other systems how to deal with like cloud transfer speeds. Like DataBox Edge and Gateway can fit in great there. And we have a couple of customer stories that kind of exhibit this as well. So Hogarth is a company that had a bunch of on-prem storage that they were using, and they got kind of tired of having on-prem storage for all the reasons that people get tired of having on-prem storage. It's kind of hard to manage, it's expensive. They didn't really want to keep sort of buying new storage systems. They wanted to move to Azure Cloud Storage, but they had this problem. They're like, oh, we got to get our stuff to the cloud, and we got to do it kind of quick because like the IT team doesn't, like they want to decommission this old machine and we have a timeline, and they were struggling just kind of getting it there. And they got DataBox Edge and like, oh, this is great, because it became a very fast transfer experience for them. They didn't have to be babysitting copies, all that kind of stuff. So they were part of our preview. They had a very successful preview, and they've continued since they've now actually transferred 5 petabytes of data to Azure Cloud through Data Box Edge and Data Box Gateway. So they've been a fantastic customer. It's just an example of like, you can do really large scale transfers through this stuff. And Cree is another preview customer that we had. Cree makes, in addition to their light bulb business, you may not know, they make these fancy silicon carbide chips that use all kinds of power transform applications like solar cars and windmills and all this stuff. And in their manufacturing process, right, they take images of each of these chips, and it generates huge amounts of data. And they have to keep them around because they kind of keep them for quality control purposes and legal purposes and compliance purposes. And they had the same problem. As they're ramping up their manufacturing, they realized, like, we don't want to ramp up our local storage to be able to store all this stuff. And they realized that Data Box Edge can help them to sort of move that data to Azure as they're sort of ramping up their production, and they can ramp up their sort of storage costs without having to buy a bunch of on-prem storage. And they use Data Box Edge as part of that pipeline. So that's an example of where they're generating data all the time through manufacturing. They move it to the edge. So now we're going to go into edge compute. And what Data Box Edge does is it runs edge compute on the box in addition to the storage gateway. And this gives you lots of different options for how to use the compute out at the edge. So like we talked about, there are still those SMB and NFS shares, and you can copy data to Data Box Edge, and you can actually build a pipeline so that all of the data that you copy, if you're copying file data to the cloud, can be run through your compute modules before it goes to the cloud to make sure that you either like cleanse the data to make sure it doesn't have like the wrong stuff in it, or filter it out, or whatever you want to do there. But also now you have this concept of lots of sensors or other systems that can talk directly to those IoT Edge modules. And every time I say module today, like that's a term that IoT Edge uses, I want you to think container. Because that's really what's going on here. Each of those modules is a container, and you can have other systems talking to those containers either through API calls or a video stream or all kinds of things. They can talk into that container, and then those containers can process data as it comes through. The containers can either use IoT Edge messaging to send messages to the cloud about results of things. They can make calls to any Azure service, right? Because they're code running on the edge, and they can make calls to Azure. Or they can also make use of that same storage gateway. So if your container wants to save a blob to the cloud, all you have to do is save a file to like your local file system, and the storage gateway will take care of moving it to the cloud for you. So here's sort of like a rough diagram of kind of how it works. So you have Data Box Edge sort of out on the side, and it connects in sort of those on-prem systems. It can talk to SMB or NFS or to your modules through API calls. Or any kind of sensor, right? So pressure sensor, video camera, any of that kind of stuff can talk into there as well. And they can all be hanging off of the IoT Edge system and be IoT systems. And then you have, up in Azure, you have sort of IoT Hub, which sort of controls all the modules and systems that are running on Data Box Edge. And then you have a variety of other services and containers. So you have many Azure services, which we'll talk about in a minute, have IoT Edge container versions. There are lots of third-party services that have built IoT Edge systems or Edge modules that you could run. And then separately, you can build your own custom modules, of course, you can run on the edge. So those all go up into the Azure Container Registry. And then you can deploy them down to your box, all specified from IoT Hub, and we'll talk about how that works in a little bit. But you can sort of deploy all these modules down to the edge and run them locally and have it all be kind of cloud managed and cloud controlled. So once again, that gets you to this place where you get to run arbitrary containers on your piece of server hardware at the edge, kind of and all managed from the cloud, which just opens up a ton of possibilities. So it's great. I mentioned this concept of integrating the storage gateway and the edge computing, and the way that you could kind of build a pipeline to make sure that you kind of inspect any files before they get uploaded. And we've actually built sort of an integration between these two systems so that it works great for you. And the mechanism for this is that Data Box Edge actually acts as an IoT device that sits downstream of your edge. And so we have this concept of like a local share and a cloud share. And the way that works is a local share is sort of an SMB or NFS share in Data Box Edge where we don't upload the stuff to the cloud that lands there, right? It's just your local kind of sandbox. You can do what you want there. You can make use of our very fast storage and just kind of have this local place where there's kind of some data sitting there. And then anything that shows up that you write to the cloud share will automatically kind of write up to the cloud. We also have this concept of that you can bind these shares up into your containers, right? So you don't have to worry about kind of authentication and those pieces from your modules. You have a way in the deployment, which I'll show you in a little bit, where the actual shares here show up as a piece of the local file system in your container, right? So all you have to do to interact with these shares from your container is it's exactly the same as talking to your local file system. So what happens is a system writes a file to the local share. And instead of you having to like know or realize that's happened, Data Box Edge knows, right? Data Box Edge sees that there's a new file there, and then it sends a message into the like kind of IoT hub or IoT edge that's running on your device. And that IoT edge sends something over to your module. And in this case, what we're talking about is an Azure Functions module. So Azure Functions has an IoT edge version. And you have the ability to write an Azure function and publish it as an IoT Edge module. And there's tools for this in VS Code, and there's kind of documentation online for how to do all this stuff. And then what happens is your function, your snippet of code, will run every time one of these messages comes in, right? So it's sort of that same serverless concept, and it's sort of reacting to events. So what your function does, the message comes in, says, hey, there's a new file, and it gives you a file path, right? It's like, awesome, new file, right? So now, your function reads from the local share. It does whatever magic compute stuff you want to do on that file. And then when it's done, it just has to write it to the cloud share, which, like I said, is just as easy as writing to a local file system. And then from there, we take care of moving it to a blob or a file in Azure Storage. And so this whole process makes it really easy to kind of both build these kind of storage pipelines that we talked about, and also just when you're doing development out at the edge and you want to think about how to kind of copy things up to the cloud, you don't have to sort of worry about this cloud transfer piece, right, or this data transfer piece. Like Data Box Edge can do that for you. So I talked about how Azure Functions exist in kind of an IoT Edge, but there's also a bunch of other things as well, right? So there's Azure Functions, Azure Machine Learning has IoT Edge modules, Stream Analytics, Cognitive Services. Cognitive Services, I'll just add a note, is super cool. So in Microsoft's AI landscape, right, we have this concept of like Azure Machine Learning is where you build your own model and you train it with your own data and you make a model like specific to your use case, which is great. Cognitive Services lets you just use one of our pre-trained models. And we actually use this sometime in demos. We're not going to use it today, but where you can like download a model, and I've done this. You download a model, you deploy it to Data Box Edge, and then you hand it an image, and it says, oh, I found some text in this image, and here's where the text is, and here's what it says, right? Like, oh, great, super cool, right? And I don't have to do anything, right? I just got this module from Azure, and I ran it. It was great. It can identify people, it can identify objects in images, it can do all kinds of cool stuff. There's AI toolkits for doing kind of more advanced AI things. There's even like SQL Server databases, and actually I didn't update this slide. Yesterday we announced a new SQL Server on the Edge version called SQL Database Edge, and they have a booth down in the expo if you want to check them out. Another IoT Edge module, like works on IoT Edge, works as part of our Edge ecosystem, and you kind of build this pattern where you have all of these Azure services, right? So you have this space that you can write your own containers, but also there's all these other Azure services that have containerized versions that can all deploy out to these edge devices. And kind of you build that kind of thing you keep hearing about where you have the same services available in the cloud and the edge, and you can kind of work across them in a nice way. And then, like I said, you can write your own, right? So modules are containers. You can put a lot of stuff in a container. We have lots of tools for writing sort of IoT Edge specific modules, but your module does not have to be an IoT Edge module to work on Data Box Edge, right? You can deploy any kind of module you want. Our modules are Ubuntu Linux-based modules, so they're kind of the most common and standard thing, and you can deploy that to the edge, and away you go. And there's lots of docs about how to kind of do some IoT Edge module stuff if you want an IoT Edge aware module. So like we talked about, right, like as you're doing all of these edge computing things, there's this concept of like machine learning becomes a very powerful tool at the edge. And there's a reason why you see a lot of the stories that we tell about how Data Box Edge works involves machine learning, because that's where we see customers getting the most value. So in general, when I think about edge computing, you're always at some level solving a bandwidth problem, right? Because that's why you're doing it out on the edge instead of at the cloud. And there's sort of two classes of this problem that we see a lot. The first class is the idea that going to the cloud and back is just too slow, right? You just need a faster result than you could get if you like sent your data to the cloud and came back. And even if your cloud connection is super fast and all that kind of stuff, you're still like, when people want like sub-second latency and things like that, right? You gotta do something locally. And so that's this concept of processing at immediate results. And I actually like to say that this is sort of a latency problem, right? So you move up to the cloud and then you come back, and that's about how much latency you have to go there and back. But this also extends even to the point, like if you're disconnected, you really have a latency problem, right? Like going to the cloud and coming back takes a really long time. So if ever you want immediate results that are faster than you can get by going to the cloud and back, right? Edge computing is a good fit. And the other one we see a lot is you have data that you want to move to the cloud, or you have things that you want to move to the cloud, but you don't have a big enough pipe for it. So instead of latency, now your problem is bandwidth. And this is the kind of concept where you're generating tons and tons of information, and you just can't move it all to the cloud. And so you need to kind of figure out how to have like a smaller set of that data go to the cloud. And this is where you get into things like, you could imagine like video camera feeds, like city traffic feeds. This is kind of, we've talked with some cities about this, where they have all these traffic feeds going by and they can't possibly save all of that data because it's a giant, huge amount of data. But maybe if they run some analysis on what's happening in those videos, they can save the interesting bits, right? So, maybe they only want to save the times when they kind of like thought a collision almost happened, right? And that can help them to study the safety of that intersection, if they can see all the times that people almost hit somebody but didn't, right? Those sorts of things. And then also there's this concept that you hear a lot of people that have sort of information that they can't move to the cloud for legal or regulatory or policy reasons. And they need to kind of scrub it, right? So they need to remove personal identifying information. They need to do other things like that. So we see this a lot in like autonomous vehicles, right, that want to move stuff to the cloud for training purposes, but they have to blur out faces and license plates, or other places where you have to kind of like remove identifying information. We're actually going to talk about that a little bit as well in a few minutes. So one of the things the Data Box Edge has is it has this onboard FPGA. So FPGAs are field programmable gate arrays. This one comes from our friends at Intel. We're here. Thanks, Intel. And what it does is it allows you to sort of create a piece of code, like it allows you to program the chip at the edge to be accelerated to exactly the thing that you need to accelerate it for. And the cool thing about this, as far as you're concerned, is that so programming FPGAs is actually kind of hard, but we build systems so that you don't have to do that, right? So we have Azure Machine Learning, which knows how to program the FPGA to be optimized for your machine learning model that's running on that specific box. And we'll talk more about how that process works, but I kind of wanted to sort of set that idea that there's this FPGA that does this accelerated machine learning. And it's part of this whole FPGA effort that Microsoft has. So Microsoft has a pretty large investment in FPGAs. We use them a lot for first-party services. So a lot of the Bing stuff in the cloud uses FPGAs. A lot of our network and storage services in the cloud use FPGAs. And we're now, we talked about it some last year at Build, and we're sort of continuing that this year. We're sort of opening up that concept of using FPGAs for third-party developers, right? So we have services in the cloud where you can kind of use FPGA-enabled services. And then with Data Box Edge, we have the Edge service to use FPGAs. So I have another customer story to share, and that's Olympus Medical. And they are doing some really cool stuff with Data Box Edge and FPGAs. And I actually have a fun video that talks all about it. We can get it to play. There it goes.
Olympus is really about solving problems in healthcare.
We see our role as to empower the staff. Let's help them do their job more efficiently and more effectively. The operating room is probably the most complex area within the hospital. It's amazing all the different services, human services, supplies, equipment, cleaning, everything that needs to be coordinated in order for a surgery to happen and to happen effectively.
One of the big problems in healthcare is the operating room and the turnover time. We have all these cameras in the operating room that we've already installed. The cameras are really there to help the staff understand room state. Today it's a manual process. We can leverage that infrastructure and we can use AI to analyze the video in real time. We have lots of data that you can't necessarily send up to the cloud and process it and send it back. It just won't give you the performance in the application that you need.
When we learned about Azure Data Box Edge, we became very excited.
The on-premise nature of the Data Box Edge and the Intel-based FPGAs make it really seamless for us to be able to integrate that device into part of our natural application.
Data Box Edge and Azure gives us the ability to interpret this video in near real time and gain insights. If I know when the patient arrives in the room and I know when the room is prepped and ready for surgery, I can let the doctor know that, and we can be a little bit more efficient about getting the doctor to the operating room on time.
It's about automating processes. We're just scratching the surface with this particular technology and the AI that it can bring, and we're just super excited to see what problems we can solve with Data Box Edge and Azure.
Oops, yikes. There we go. Sorry. And we actually have Mike Thornton here, who's in the video. We're just going to have him talk for a few minutes about sort of using Data Box Edge and the problems they're solving. So welcome, Mike.
Yeah, thanks. Yeah. Good morning, everyone. Thank you to Chris and the Data Box Edge team and the Brainwave teams for collaborating on that video. It was a tremendous experience of ours.
Quick note, Brainwave is a Microsoft name for the FPGA stuff.
Olympus is a global medical technology and manufacturing company. It's an imaging company that provides devices for therapy, diagnosis, and treatments of patients. The Olympus Customer Solutions Group is a group that has 20 years of experience focused on solving problems in healthcare and really the patient experience. Our focus is really about enabling technologies such as Data Box Edge to solve some of these problems in the operating room. As Chris mentioned, there's bandwidth issues, there's lots of problems taking all this data that we collect in the room and processing it and doing something with it to solve some of these customer problems. Many of the problems that we encounter in healthcare are really around efficiency. And things such as just getting the physician to the room on time to start a surgery is a big problem. And many institutions are really focused on gathering data to try and improve that physician getting to the room in time. There's also turning the room over. Many hospitals have an issue just getting the cleaning staff into the room to clean the room in time, to get it set up for the next patient. And with technologies such as ours, with the various cameras that are already in the room, we can use the Data Box Edge to analyze the video, provide feedback, and then notify the cleaning staff or the managers that it's time to get a patient there. We can do that automatically. And then there's lots of other problems that we can solve with Data Box Edge to enable some of these great technologies. Yeah. But it's a super start for us, and we're really excited.
Totally. And so one of the things that I think is really interesting about this is that you, like, this idea that, like, you already were capturing this video. It's like it's sort of already an asset you had. Yeah. Right? And people were looking at it, but, like, you kind of, like, you can bring in, like, sort of this machine learning technology to be able to kind of get automated stuff out of it, right?
Right. We have a product that's called Status Board, which is typically located at the nurse's station. It's kind of the central location inside operating rooms, and some of these might be 40, 50 different operating rooms. And you can walk up and you can visually see what's going on in all these different operating rooms. This one's in cleaning, this one's in the middle of a procedure, this one's about ready to finish. And it helps the staff just kind of coordinate and understand what's going on with with all these cameras that we've already got, we can process this data and help automate that step.
And one thing that, helped me a lot was when we were talking and you said, like, it turns out that, like, because you had, like, obviously, like, you could build, like, a little button, like, oh, the patient's in the room, right?
Right.
But there's a lot of reasons why that's not as good as, like, doing it automatically.
That's a great point. One of our core products is called Easy Suite 4K, and it's kind of like a home theater for the operating room. It brings together cameras, video, image capture, room state, and there's certain buttons that the user can click to transition from one step in the procedure to another. Those telemetry signals, along with the actual video itself of the room state and the awareness, can help gain a lot of insight into what's going on in that room and enable some of these really good efficiencies.
But also you talked about how, like, you don't want to give the staff more to do because they're like,
yeah,
busy.
that's a great point.
Making them press a button, like the patient's here, right? Like they forget and your data is not quite right, and then like also it's just one more thing for you to do.
That's a great point. There's something called the triple aim and the quadruple aim. I won't go into detail on that, but the quadruple aim is really about staff burnout and staff satisfaction, as well as the patient satisfaction, the outcomes, the efficiencies. But you don't want to add more to their workload. Their focus is on the patient and solving that patient's problem, whatever it may be. Not worrying about another device that's been wheeled in, what cable do we connect to the wall, where do we do it, do we take the high def, do we take the 4K signal? What we really believe is we try and make it simple and easy for the staff so that they don't have to worry about all the technology in the room. Don't add more tech just to solve a problem. Use the existing technology to make their job easier and to focus on that patient.
And then overall, as you've kind of worked, kind of pulled Data Box Edge into your system to add sort of AI, Microsoft AI Smarts kind of into that, like how has that experience been and kind of like plugging it into your system and that kind of stuff?
Yeah, so we've had the Data Box Edge installed in our data center for a few months now, and we've been building a prototype application to take the video that's already on the network, decode it, send it up to Azure, to decode it, process it there, and then provide the results back to the room.
Right. Yeah, and that all kind of fit into your existing stuff in reasonable ways.
It fits into our existing kind of platform, the way we work, the tools that we use, and it's been actually fairly seamless.
Great. Okay. Yeah. Thanks so much, Mike.
Okay. Thank you.
Yeah. Thanks for coming. So I have a few other kind of customer stories. So Kroger, we actually have on the expo floor downstairs, we have a Kroger setup. And Kroger is doing a very similar thing to what you just heard from Mike and Olympus. Kroger has existing cameras in their stores. They kind of know how to look across the stores and see things, but they don't actually know how to like process that. Like say it's a person who kind of looks at it to kind of like make sure nobody's shoplifting or something. And what they can do is they can put Data Box Edge in there and they can solve this sort of surprisingly interesting problem, which is that stuff being like physically on the store shelves is actually a huge problem for retail, right? Like if somebody walks up and takes the last thing of a product, like they want to get the thing out of the back and put it out on their shelf. And it turns out that they actually lose more money in sales to stuff being not on the shelf than they do to people stealing stuff. So it's a giant problem, right? And to be able to get more efficient at running their stores, right, just even knowing like when something's no longer on the shelf is a big deal. So they use Data Box Edge to do that. And we actually, like I said, have a live demo of that down on the expo floor. So you can kind of walk up and like, take a box of cereal off the shelf and it will see, oh, look, there's no more cereal there, right? And notify somebody to go put more cereal back on. So you can see that over in the expo. Esri is another one of the customers that we work with. So Esri does a lot of work with natural disaster response, and this is like kind of more of an offline use case, right? So Esri is a mapping and kind of spatial company, and they already have software that knows how to sort of get footage from drones or like people on the ground and update sort of map information with what's going on there, right? It's like what structures are destroyed, where are there people that need help, like those sorts of things. But a lot of times there's a team that's working out somewhere where they don't have bandwidth, right, to go up to the cloud and kind of update like the master maps. So what they can do is they can send them out with like a local copy of their maps and their mapping software, and then as they get kind of footage back from drones or from other things, they can use that footage to automatically process it and update the mapping systems and direct sort of the response out in the field to where it needs to go. And then we have, so Mill5 actually is a solution integrator or a Microsoft partner that's been working with Olympus on sort of all of this at Data Box Edge. And so what we're going to do actually is we're going to show you a demo of the video that we just talked about, or the kind of that same stuff, and what Mike talked about sort of their sort of prototype app to sort of do all of this and see this piece. So I'm going to start that demo as Shri comes up. And I mentioned that Data Box Edge overall is this cloud managed thing, right? And what that looks like is that here we have the Azure portal. And inside the Azure portal, Data Box Edge has a resource, right? So your Data Box Edge is at your site. It's all controlled from the cloud. This specific Data Box Edge, we're actually going to talk about 2 different ones briefly, and there's actually a fun story around that here as well. This specific Data Box Edge is actually in a lab in California. And I'm not connected to it, right? I'm just connected to the Azure portal. And I can see on it that it has, we can see some basic stuff about it. We can see the kind of shares we talked about that are all kind of set up, modules and things, and also sort of on this resource pane, we pull in like kind of the modules that are running on it. And so there's all these different modules that are running. And really what this is, like I said, the control plane for all of this is IoT Hub and IoT Edge. So what I'm going to do is I'm going to switch over to the IoT Hub that's controlling this thing. So this is the IoT Edge device, right, from IoT Hub. And IoT Hub is, it's a developer tool, right? I want to be really clear about that. But it lets you to deploy all these modules. And what's nice about it is that in addition to doing kind of some of the stuff that I'll show you today, just sort of on the website, right? Like at some level, this is just a wizard to generate a JSON deployment script. And that JSON deployment script can be used with an API in Azure to sort of deploy to wherever you want, right? So you can deploy to an individual Data Box Edge. You can deploy to a bunch of different Data Box Edges. You can sort of tag your Data Box Edges as in different buildings or different workloads and use a single deployment script to deploy to everything with a certain set of tags, right? They have all these sort of management functionality for deploying across kind of a fleet of devices. And so this is a list of modules. The Edge Agent and Edge Hub modules are part of IoT Edge. That's sort of part of the functionality there. They're denoted with the $sign at the front to mean they're special. And then after that, we have this app that Tree and Olympus have built, where you have the variety of these different modules that all do different jobs. So I'll highlight a few of them. The Fabric module is really cool because it just it accepts kind of commands from the cloud and sends them back. And Shri will kind of show you how that works. This SSD VGG image module is one of those Azure ML modules that I talked about. So this is a container that comes from Azure ML with a trained model specific to their use case. And what happens is when you install it on the device, it finds the FPGA card and it reflashes the FPGA to kind of optimize for SSD VGG, which is one of the models, one of the machine learning models, and then can run that model. And then the other kind of big one is this InfoScene management module. That's the one where all the kind of smarts of the thing are, and that's kind of how it works. And the key is all these modules, right? They're all containers that are running down on the client. And there's a few ways for them to communicate. IoT Edge has a messaging system that you can take part of. And when I talked about an IoT Edge aware module, that's sort of what I was talking about. You can kind of get those IoT messages and you can send them kind of onto another module or onto the cloud. But also, IoT Edge sets up a local Docker network for you, and it uses Docker DNS down there as well. So you actually can just do a lot of communication straight across, right? So these modules actually, I think this is right, all communicate just with API calls between them.
That's right.
Yeah,
one of them using gRPC and the other.
Right. Yeah, exactly. And all you have to do, you just have to be send my API request to, SSD VGG-image : port number, right? And you can do all that communication locally between the modules. Specifically, when you actually go to deploy modules, right? Like in the UI here, you kind of set modules, and that creates the wizard I talked about that kind of can create this deployment JSON. So overall, you have all these different modules, and you can configure them. So for example, this inference management module is a good one to talk about because it has a lot of stuff going on. So you have, the normal thing, you have the name of the module, you have the image, the place where Docker should pull the image from. And then you have this variety of, you can set environment variables, right? So if you want to set, this is the best place to do, I want to set a configuration that doesn't require me to recompile, right? So you can set an environment variable for your module. So these are a variety of things, right? So it's telling that, oh, when you're calling this, when you're calling the Azure Machine Learning module, this is the name of the module to call, and this is the port number to use, right? So then the module, when it's running, just kind of pulls that out of its environment variable, and away you go. So you can set all of that through a configuration instead of having to hard code those pieces. They can be different across your installation. And then the other key thing to talk about is this concept of, when I talked about binding shares up into the modules. So what we do is, like I said, we had these local and cloud shares, and those are just the shares that we've created over here. So you see over here, I have a share called local and a share called cloud. And the cloud one, is connected up to my sort of storage account, right? So anything I save to that will go to the cloud. And over here, I bind that local share and that cloud share into something in the module's local file system. So when this module is running, and you'll see there's this process when it's running that we sort of save an image file from the video just to kind of make the demo kind of work and help you understand what's going on. And what he's doing is he's actually saving that in his local module, the /home/output/file name, right? And the Data Box Edge automatically uploads that to cloud storage for you. That's all you have to do. And then, so once you have one of these things, you come through here. This is routes, which is sort of how to route IoT Edge messages around if you're going to use those to kind of talk between modules. And then at the end, you have this concept of, like I said, this has just now generated this JSON deployment manifest. It has all these different pieces. It has all the modules. It has all of the kind of things that you would want to use for those modules, like environment variables, the Docker create options, which are those kind of config options, and all those pieces. So like I said, it's the concept of, you're just deploying containers to the edge, and you can specify the Docker create options for them. You can specify environment variables for them. You can do all of that kind of from the cloud, and then click a button, and it will deploy all that to the edge. So, and then we'll have Sri show you what that ends up looking like.
All right. So what you're going to see now is a small portion of what Mike had described as the larger solution that Olympus is actually trying to build, right? So this application, what you're seeing, is a test app that engineers actually use. We have these IoT modules. We have the machine learning model that's actually deployed on the Data Box Edge. So what we use this application for, we rely on it quite a bit, is to make sure that the changes we make and the deployed, modules and model on the Data Box Edge are doing the right thing. So, we get a lot of the test data back into this application. We're able to look at it, fine tune it, and then push it again, run the telemetry and invoke certain things on the Data Box Edge, because again, it goes through the IoT Hub stuff, right? So we're able to send device telemetry into it, invoke certain workflows, specifically with in the Fabric module that Chris was talking about, and it goes through its inference. We're able to look at what it's actually collected, and it surfaces up here. What I'm going to do, like Mike said, there's a certain workflow that happens, in a procedure room. So doing a register patient here calls into the Data Box Edge and sends it a telemetry that a device in the procedure room would normally do, right? It's basically before, a patient gets, worked on, there's a registration that happens in the room, and that's the message that I've actually sent it. And for these demo purposes, instead of looking at a live video stream, we have a snippet of video that we've stored on the local share on the Data Box Edge, and I'm going to send it a command by clicking on the capture video, which tells the Data Box Edge to load up this video and then start doing its inference on it, right? So this is the video that we're actually playing, or the Data Box Edge is actually picking up and reading. To the right of this video, you'll actually see the frame that causes the the actual inference success, and
What are you looking for? You're looking for a patient coming in the room, right?
the patient coming inside the room on a gurney. And it's going to find that, it's going to highlight it right here. And you also see other frames, of varying confidence that it actually identified, and this helps us sort of, fine tune it a little more, right? In a normal production scenario, obviously you won't be, sending these images out of the Data Box Edge because for compliance and regulatory purposes, right? So, but for these testing reasons, it's a great thing to do, right? And what it's doing is writing it to the cloud share on the Data Box Edge, and Data Box Edge does its magic, sends it over to to Azure, into blob storage. And what this application is really doing is just retrieving those images down and displaying it out.
And what I think is actually kind of neat about this, which does not necessarily make sense for in a testing app, but it helps especially for demo logistics as well, is that you're not actually connected to the box, right? This
That's
box
correct.
is in Boston.
Is in Boston.
Right. And so what you did was you sent a message to the box through the cloud, right?
Correct.
To say hey, start processing.
Yep.
And then it processed on its own, and then when it found something, it sent a message back to you through Azure saying, hey, I found something, and here's the path in Azure storage where the result is.
That's correct.
Right, and then you just load it up here in your application.
Yep.
Right, yeah, so you have this kind of even though you're doing all the processing down at the edge, you don't have to kind of have something, you can kind of do all this routing out through the cloud and have it all be cloud controlled.
Exactly, leveraging the IoT hub to do all of this stuff.
Yeah, exactly.
In a big way.
Does anybody have, well, we'll do questions in a little bit, but there's thanks so much, Sri. This is
Yeah, you're welcome.
great. Yeah,
Cheers.
absolutely. So there's one more project that I want to talk about briefly, and that's this thing that we're doing sort of internally and on the Microsoft campus. We have a bunch of parking lots, and it's the same concept again. It's this idea of infrastructure you already have that you can make smarter. So we have a bunch of parking lots on the Microsoft campus, as you can imagine. We have a bunch of employees. They drive to work. They need a place to park. And we've actually kind of started working with our facilities team about, hey, how can we make some of the parking lot stuff more efficient? And what's really actually interesting is some of the garages on Microsoft campus, the new ones, have all this really fancy stuff, right? They have they have all this hardware above each parking space and a little light that knows if a car is in them or not, and you can tell where cars are, and but obviously that's sort of pretty expensive to outfit the garages with all that stuff. And so we've been talking about hey, you already have cameras, right, that you use mostly for security and facilities purposes. What if we could figure out what's going on in the parking lot just from those cameras? And so what this is a map of one of the floors of the parking garage, and kind of overlaid on top of it is the camera coverage that exists for the existing cameras for those, and kind of what they see, and sort of some sample images that come from each of those cameras. And what we've done is we're kind of building this thing that can kind of look at those images and kind of figure out what's going on. And then once it kind of figures out what's going on in the image, it can kind of map them to what's going on in the parking lot, and kind of the same idea of getting kind of things out of the data. So here you have this concept of the original image, and then cars that we detected by running an AI module on Data Box Edge. And then also this idea that we talked about sensitive info removed, right? If you want to be maybe saving this data or doing something with it, right? This is an auto-generated thing. You can tell it's not super sophisticated. We detected cars, and then we blurred out the box where the car was, right? Sometimes you don't need to do super crazy stuff. Sometimes you can just do kind of simple stuff. And that's actually, I think, one of my favorite things about the Olympus scenario as well. There's a lot of times with machine learning, we're trying to do these really complex, hard things, but sometimes you can get a lot of value just by doing the simple stuff, right? Having a fixed camera in an operating room identify when a gurney comes in and out of the room is actually, on machine learning scale problems, not a super hard problem, right? It's relatively easy to kind of train that model. There's only one camera, there's a fixed lighting set, it's in a static location, right? Most of the equipment in the room, kind of is sort of generally static. There's a lot of people in the room, but the concept of a big horizontal table with a person on it looks a lot different than all the other stuff. And all you gotta know is it went in the room and it went out of the room, right? So the surgery is ready to start because the patient is there, and the surgery is done because the patient left, right? And doing sometimes just doing those little things can get you a lot of value. And I think that's kind of one of the really neat things about kind of looking at these existing kind of pieces of data that people have available to them and trying to figure out like, hey, how can we add a little intelligence to this? And we don't necessarily have to do like super hard, crazy stuff. We can just look for the easy things and start there and build from that. So this, this is kind of how the parking lot image works. It's the same kind of concept, right? So we have, a bunch of, we have the parking lot. Actually, and I'll talk about the Unity stuff in a minute, which is also a pretty cool idea. So you have the parking lot, and then that comes into all these containers. Those, so you have here in the set, you have the image acquisition containers, and that's a container that's sort of designed to pull data from each sort of video feed or each camera feed. Obviously, most of the time with this stuff, you're using, you're kind of doing test data. So you don't actually have like a live camera feed, but what we can do is, and what we've done is we set up sort of like this archived video. They can kind of sort of broadcast a sort of a test feed, and then those containers can kind of pull that feed down. And then it runs through object detection. It organizes the frames to figure out what's going on. And then from that, it can kind of like compute kind of what's going on in the parking lot with all those different pieces. And then it kind of uploads things to Azure Files in this case. And then, the developer for this wrote a Azure App Service on Linux, which is up in the cloud. And that's sort of a web page, right, that allows you to have a dashboard of what's going on in the parking lot. And it actually has, does do the thing where it uploads kind of some desensitized frames, so you can kind of get a sense of what's going on in each place if you want to kind of click through or see if something looks weird. And it uses IoT Hub, Cosmos DB for some of the storage stuff, all those pieces. So it's the same idea that you have something at the edge that's running, and it's kind of calculating these things down at the edge, but then making kind of full use of the cloud. Do you have a question? Right. So the question is if we train the model in Unity, and then deploy it on real feed. And so what's happening here is sort of two things. So we train the model with the video, but then we also use Unity to supplement that training data. And so what Unity allows us to do is build synthetic data that allows you to, so we built sort of a Unity model of that same space, and we use the video plus additionally kind of this concept of synthetic data, right? Synthetic data to train, and you put it all together, and it does actually increase the value of the model. Yeah, so he said that's interesting to use the concept of using synthetic data to train and then use it for reality stuff, which is something that we've seen a lot, this idea that you can use synthetic data to supplement real data in order to do training, because real data is sometimes hard to get, right? And especially if you want to sort of train on certain circumstances or certain things you want to create, it's a lot easier to create that when you have control over the environment, which you do when you're doing something kind of in a simulated or synthetic environment. So overall, I like to talk about the way that compute modules have these sort of endless possibilities, right? And we've talked about a lot of those today and a lot of the different ways to do things. But it's really just this concept of you can do these serverless event-driven Azure functions. You can filter out values. You can process data. You can run, you can read video streams. You can call out to other Azure APIs. You're not limited to what's built in and kind of help in the box. You can do local API calls either in or out of those modules, right? So your module now is running on your local network. It can do an API call to a local system that you have and kind of interact with those local systems. Your local systems can do API calls into your modules. Sort of all those things are all possible with these containers running on the edge, because you're deploying kind of whatever compute you want in a container down to the edge. And this is my architecture slide, right? Classic joke. And so overall, you see Data Box Edge kind of in the left over here. And it has those three things I talked about. It has its sort of local, kind of cache storage. It has its IoT Edge modules, and it has that FPGA with Azure Machine Learning. And it has this optimized data transfer to move up to the cloud. Sensors can talk into sort of the IoT Edge system. Your on-premises data can talk to the local storage through those SMB or NFS shares. And really, there's this concept here, too, that I want to talk about, this idea that even if you don't necessarily want to save all your data at the edge, the storage gateway can be really useful when you're doing machine learning, because you can be processing the data as it comes in, and maybe you get a result that you don't quite understand, or you get something that's in your kind of gray area of confidence level. You can take the source data for that and write it to the storage gateway. We'll save it up to Azure for you. And then you can now have it up in Azure and you can use it to retrain your model, right? So you can go and you can look at that data that confused your model. You can then go and kind of like label it, figure out what's really going on there, and then crank it back through the Azure Machine Learning system, create your new model. And then because we just talked about how easy it is to deploy things down to the edge, and your model is just a container, you just add it to your next, you add the new version of the model to your next IoT hub edge deployment, and we'll deploy that container back down into the edge, and you have an updated thing. So it's this sort of ecosystem or workflow of improving your machine learning models, even out in the field, that you can do by detecting kind of what's not working and then getting that source data up to the cloud. Talk a little bit about Azure Machine Learning. So overall, there's an Azure Machine Learning service, and it has a variety of different ways to kind of build and train your models, right? So you can use, there's command line interface, there's VS Code, there's notebooks, which is kind of the most common thing that we kind of use and see internally. There's open source Python IDE stuff. There's all these different ways to kind of, and the goal with the Azure Machine Learning team is to kind of let you use the tools that you're used to train an Azure Machine Learning model. So when you train that model, then also you can use local resources, you can scale out. We're using Azure Machine Learning Compute, right? So we obviously have a wide variety of cloud services that you can use to run compute things and train models. And then also Apache Spark is supported by Azure ML. And overall, what happens with these things, though, is that, like I said, you get that model, and then you call into Azure Machine Learning Service, and it will create for you the Docker container that we talked about, right? And that Docker container you can now use to deploy on-prem through IoT Edge, kind of any IoT Edge device. You can run it in Azure container instances. You can run it in the Azure Managed Kubernetes service. You can do some IoT accelerated targets. And of course, the one we're talking about today is it can target the FPGA on a Data Box Edge. So when you install that module, when it boots up and starts, it finds the FPGA device, it flashes it, and then it flashes it with the acceleration for your model, and then away you go. We talked a lot about cloud managed. Let's say again, you saw the demo that the whole thing is managed from the cloud through the Azure portal. And I guess there's an important point there, right? You can configure the system, monitor health, install updates, right? So if you want to update the system, that's a button or an API call in the Azure portal. Pricing is really important. Data Box Edge costs $695 a month, and then it's available in the United States and in the EU today. We're working to expand that quite a bit. Like I said, that price, you don't have to purchase the hardware. Use of the hardware is included in that price, and you pay as you go. So you get this large server class machine, which is, like I said, it actually has 2 Intel Xeon processors in it. It has 12 terabytes of local flash storage. It's a giant pile of fast storage. It's a 1U server. It's got a ton of networking. So it's got all these different things that you can use for all that purpose. And then kind of, and away you go. We think it's a great value at the price point it's at, and you don't have to buy the hardware. Like I said, there's no kind of capital expenditure. There's something to kind of keep on your books, those pieces. Yeah. Yeah. And all these slides will be available as well, kind of through the build site as well. So availability, like I said, it runs only in certain Azure services, but you can connect to any storage account kind of worldwide. So the availability for the Azure region is just about what region you use to control the device. And then, like I said, you can order it today. So you can go to akms.databox-edge, and that'll drop you in the right place in the Azure portal to order a device. Or you can just search for it in the create a new resource thing in Azure, find Data Box Edge there, and get to that same place. I will say we always value your feedback, so we'd love for you to fill out a feedback thing after your session. Thanks so much for coming. There's like a minute left if anybody has any questions, and I'll be up in the front as well afterwards for questions. Yeah.
Hello.
Hi.
I got a question about 2 critical techniques for the edge devices. First is how do you handle the streaming data? I know the event hub or the service bus or even the Flink, they are too heavy for the edge. That's the first part.
You mean to Sorry, to like stream data to the cloud? Or, oh yeah,
Device.
okay.
For the edge device, you have to handle the incoming streaming data, right?
Yeah, so usually what happens is you have your module, which either will read like an RTSP or a streaming image feed. Are you talking about video images or?
You mean you don't have the embedded, like embedded IoT?
We right now don't have tools that do that automatically. I think in the future you might find some of those other Microsoft services I talked about with edge tools might have those.
Okay. The second part is how do you secure the box, especially data and applications on the box?
So the box itself is an appliance model, and so it runs sort of with. So we have kind of full we have sort of the security you'd expect for a machine as a TPM chip. It has all those pieces running on it, but the actual kind of login process you use. So you use the Azure portals. So you want to secure your Azure account, and then we secure to that, and then locally you kind of access it through username and password stuff. Yeah.
What type of data gets stored in the provisioning regions?
In the provisioning regions, that's just configuration data for the box. So it's things like the name of the resource, the name of the box, the name of the name of the shares and what storage account they're connected to, those sorts of pieces. Yeah. There's none of the file data ends up there. Yeah.
Thank you.
Yeah. Yeah.
One quick question. So for the use case that was shown, Fabric app or something that Olympus had built, right? If I'm developing a version 2 of that app, can I deploy from Azure portal that custom built app down on as a containerized module and replace the existing one, like something of zero
you can
time upgrade and stuff?
Right. So when you deploy a new version, you just specify a new deployment, and it will replace your existing thing and deploy the new one on top of the existing one, if that makes sense. Like it takes down the modules and turns and puts up the new one.
There are 2 modules. I deploy this one and then phase out the earlier one.
It doesn't do a phase out. It takes it down and then starts up the second one. So you do incur a little bit of downtime there.
All right. And one last question.
Yeah.
How we are maintaining the high availability down at the IoT edge? I heard someone's session about Kubernetes cluster empowering IoT edge. Is that the way?
It's something we're working on, and you'll hear more about that soon. Yeah. Okay. Thanks very much, guys. I got the red light up here. So enjoy the rest of your conference. Thanks.